Welcome back to Resilience. I'm John Biggs. Today we're talking to Peter Podesser. He's the CEO of SFC Energy. You have delivered combat-proven fuel cell systems worth approximately $42 million to Ukraine very recently, Peter. So welcome.
Well, thanks for having me. A pleasure being with you. Yes, this was a major, call it step or win, providing resilient, easy to deploy power systems based on fuel cell technology for defense and civilian applications in Ukraine. Naturally, there's such a decision is always the outcome of a proper preparation process. We had our systems out there in the field for quite some time, and now it got to a, let's say, decent volume of business, ensuring dependable, reliable power with, and I think that's very important, with, let's say, less weight than comparable other systems, other power supplies, but also, and I think that's the decisive point with the changing environment in modern warfare, virtually no noise and no temperature signature.
So these are hydrogen fuel cells, or how do they work?
Well, most of it, I would say 95% is all based on a liquid fuel. So we are using methanol as the energy carrier.
Interesting. Okay.
And therefore, logistics is also pretty easy because it's still a widely used organic alcohol that is also easily accessible. Well, naturally, you have to put it in a proper canister and lid it properly. But at the end of the day, easy logistics.
Okay. So basically, the goal is you have a cube. About how big are these other fuel cells?
Well, if you imagine starting from, let's say, man-portable, this is like a water or milk bottle.
Oh wow!
The let's say next bigger size is like a jerry can, and then larger stationary systems, they can go up, let's say, be it in a pellet case, or also in 19-inch standard industrial racks, but still all based on modular design, always also being transportable and therefore easy to deploy, and then also to, let's say, remove and be mobile and agile in terms of applications.
So it seems like this is I've been hearing about fuel cells for a long time. When I think fuel cells, I go straight to hydrogen, right? What is it about this technology that's made them this easy to, I guess, deliver at this point? That big a contract requires these things to be fire and forget to a degree, right?
Well, if you look at it, we've been in this business, one of the pioneers there, with a clear focus on stationary and portable power. And therefore, as said before, a liquid fuel helps also to set up proper logistics and in different regions. And our defense and military work goes back more than 2 decades, actually 25 years ago. We started to develop those systems for our own forces here in Germany, but also with dedicated funds here from the US Army. And it was always targeting lower weight and smaller form factor. By hybridizing fuel cells with batteries, you still keep the infrastructure unchanged. The battery is there as a storage media, as well as covering the peaks. And the fuel cell is, at the end of the day, the lightweight, silent battery charger. And where possible, we combine it also with solar capacity, and therefore bring down operating hour and fuel consumption, which especially in our industrial business, which is about 2/3 of the overall business here that we do worldwide, we're making it also, let's say, financially viable model and competitive in a commercial sense.
Mm-hmm. So in terms of how this works in the field, so a soldier could basically carry this, or someone could carry this, dual use, let's say. Someone could carry this and plug a device into it through the main, like a main style or a USB style, or is it just like a little generator sort of thing?
At the end of the day, it's complementing the existing infrastructure wherever soldiers or within an equipment, batteries are used, wherever there's okay. No grid, or you need to complement the grid. The fuel cell is combined with the battery, with the, let's say, necessary also power electronics, and either you charge the battery also, or you operate the device directly. It means with what we call the power management devices, then you have also a device that's the universal interface. So whether this is a communication device, whether it is in a vehicle as an auxiliary power source where the vehicle then can operate in silent operational mode without starting the engine, being able to do all communication and sensing that is needed, or be it, let's say, for an unmanned vehicle, ground or air on batteries, you can add this on and you extend range, or you simply charge the batteries without creating, again, a signature and being detectable.
Is there any specific thing that made these particularly interesting right now? Is there a technology that's changed over the past few years that made it easy for you guys to sell these?
Well, I think that technology, we progress this, and at the end of the day, it's two main domains where the improvements happened. It's about, let's say, making it smaller and increasing the power output per form factor, so easier to integrate, easier to transport. And I think what the structural change is that we see, and what is the driver also for this kind of technology now being used in active combat situations and war situations like in Ukraine, is the fact that most of this modern warfare goes electric, and the need for electrical energy has quadrupled or is now tenfold the level compared to a couple of years back. And then again, the fact that you can then charge your batteries, you can operate and power your devices without being easily detectable, I think is the element that gave it tremendous momentum right now. Technology development over 20 years, yes, with, as I said, armed forces across the globe, I'd say, made us being qualified. But I think right now it is more not just having a NATO qualification, it's about being used where modern warfare is happening.
Okay. What's next for the technology? Where do you see this expanding to?
Well, I think next is two things. The one is naturally, again, reducing the size and increasing power output and being, let's say, fully hybridized, as mentioned, with solar and fuel. And then also by using AI-based tools, making, let's say, or having a better analysis on all the gathered data to make it, again, more adapted to specific scenarios of usage. Talking about, let's say, what is the ambient temperature, how many hours of use, and then optimize it for a longer operation and less fuel consumption.
Fascinating. All right. So you guys are delivering now. What's the timeline for delivery?
Well, it's all within this year. As you can imagine, there is actual, let's say, significant demand, and let's say beyond this activity, we are also naturally also expanding our activities. Just right now, being here in North America, we've started our production operation in the US recently, not so much to counterbalance, let's say, a tariff regime in place, but more because of simply the expectations of customers to be onshore. We have built up a similar operation in India before, also for defense and border security, for the defense and border security market, and we're increasing our international footprint also in other parts of Asia, for example, in Singapore.
All right, excellent. Well, Peter, thank you for this. This has been a nice explanation of modern fuel cells.
Well, thank you, John.
All right. This has been Resilience. I'm John Biggs. We'll see you next time.